Let's start with the size. Our sun is a giant. If you hollowed it out, you could fit over 1.3 million Earth inside. That's a lot of sunshine. The distance between the Earth and the Sun is not constant throughout the year. This is because Earth's orbit around the Sun is elliptical, not perfectly circular. The average distance between Earth and the Sun is about 149.6 million. There are two key points in Earth orbit: perihelion and aphelion. Perihelion. This is the point in Earth orbit where it's closest to the Sun at a distance of about 147.1 million kilometers. This happened in early January. Aphelion. This is the point in Earth orbit where Earth is farthest from the Sun at a distance of about 152.1 million kilometers. This happens in early July. Imagine you have a super fast car that can travel a crazy speed of 200 km per hour. That's incredibly fast for a car, but not even close to reaching the Sun. To travel from Earth to the Sun at 200 kilometers per hour, it would take a mind-boggling 170 years to reach our destination. Imagine a commercial airline like a Boeing 747. If it could fly continuously at its cruising speed of around 900 kilometers per hour, it would take approximately 167 days to reach the Sun. The Sun emits all colors of the visible light spectrum in roughly equal amounts. When these colors combine, they create what we perceive as white light. This is why we see a variety of color on Earth under sunlight. Sunlight is not purely yellow or orange. It contains all the color needed to reflect off objects. However, when sunlight travels through Earth's atmosphere, some of the shorter wavelengths, like blue and violet, are scattered more easily. This leaves a higher proportion of the longer wavelength, like red and yellow, which reach our eyes. So the Sun often appears yellowish, especially near sunrise and sunset, when the light travels through a thicker layer of atmosphere. If you could see the Sun from space, where there is no atmosphere to scatter light, it would appear much closer to its true color, white. Believe it or not, our Sun is about 4.5 billion years old, which puts it right in the middle of its expected lifespan of around 10 billion years. So the Sun has a good long while left to shine bright. Speaking of shining bright, the Sun is incredibly hot at its core, where nuclear fusion happens. Temperature reach a sizzling 27 million degrees Fahrenheit. That's hot enough to fuse hydrogen atoms together, releasing the energy that powers our entire solar system. But what exactly is nuclear fusion? Alright, let's talk about the engine that powers our Sun. Nuclear fusion. It's completely different from what happens in nuclear power plants here on Earth, which is called nuclear fission. Imagine two tiny balls of Play-Doh. In nuclear fission, we take a heavy nucleus like uranium and split it into two smaller nuclei, releasing a lot of energy. Fusion is the opposite. Here we take two very light atomic nuclei like hydrogen and smush them together to form a heavier nucleus like helium. This process also releases a tremendous amount of energy. Even though the atoms involved in fusion are very small, when they combine, the energy released is immense. That's because a tiny bit of mass gets converted into a huge amount of energy. But there is a catch. Positively charged protons in atomic nuclei naturally repel each other. To overcome this repulsion and get them close enough to fuse, we need incredibly high temperature, millions of degrees Celsius. That's exactly what happened inside the sun core. The sun gravity creates immense pressure, squeezing hydrogen atoms together at scorching temperatures. This allows them to fuse and release the energy that reach us as sunlight. Do you know the element helium is named after the sun? Scientists first discovered helium by analyzing the sunlight during a solar eclipse. The sun's surface is not always smooth. It has dark, cooler regions called sunspots that appear and disappear in an 11-year cycle. The sun has two main regions, the interior and the atmosphere. Within these two regions, there are 7 distinct layers, each playing a crucial role in the sun function. The first layer, core, the sun heart and the hottest part. Here, under immense pressure and temperature around 27 million degrees Celsius, nuclear fusion takes place, converting hydrogen into helium and releasing tremendous energy. Radiation zone. Above the core lies this dense region. Energy from the core travels outward as radiation, slowly diffusing through this layer like heat radiating from a hot stove top. Convection zone. The outermost layer of the sun, interior hot plasma constantly rises, cools and sinks, creating a churning convection current that transports heat toward the sun. Photosphere, the visible surface of the sun, where light is produced. It appears grainy due to the convection and has a temperature of around 5500 degrees Celsius. This is the layer we see during a solar eclipse. Chromosphere, a thin layer just above the photosphere. It appears reddish in color during a solar eclipse and is the source of solar flares and prominences. Transition region, a narrow zone between the chromosphere and corona, where the temperature rapidly increases. Corona, the sun's outermost layer, extending millions of kilometers into space. It's surprisingly much hotter than the surface, reaching millions of degrees Celsius. The corona is the source of the solar wind, a stream of charged particles that flows throughout the solar system. Each layer plays a vital role. The core generates the sun energy. The radiative and convection zone transport it outwards, and the atmosphere releases it into space, influencing Earth climate and auroras. The sun has a super strong magnetic field that stretches far out into space. The magnetic field can affect Earth's atmosphere and cause auroras. The sun is a luminous powerhouse, but did you know that only a tiny fraction of its light spectrum actually reaches Earth's surface? Our atmosphere acts like a giant filter, absorbing most harmful radiation and letting in the beneficial light we need for life. The sun is not always the same. It goes through an 11-year cycle of a high and low activity. During periods of high activity, there are more sunspots and solar flares, which can impact our satellite and communication system here on Earth. The sun is constantly blowing a stream of charged particles called the solar wind. This wind can travel millions of miles per hour and can cause beautiful auroras when it interacts with Earth's atmosphere. Speaking of auroras, these dazzling display of colorful light in the night sky. Looking to the future, the sun offers a powerful solution for a clean and sustainable future: solar energy. By using solar panel, we can capture the sunlight and convert it into electricity.